Hello everybody. Today I'm going to go over step-by-step 2, lesson 4.2, question 14 from section 4.2, linear relations. So we often do these step-by-step questions in class and they correspond to a question from the book. So on page 172, I believe, that's where question 14 can be found, assessment focused. And the question says, Danica is having a party. She estimates that she will need 3 pieces of pizza for each guest invited and 6 extra pieces in case someone shows up unexpectedly. A then asks us to explain why this situation can be expressed by the equation P equals 3n plus 6. What do P and N represent in the equation? Okay, so if we look up here, it tells us up top here, it says, Danica is having a party. She estimates that she'll need 3 pieces of pizza for each guest. So that's telling us we're going to need 3 times the number of guests. And 6 extra pieces in case someone shows up unexpectedly. So P would stand for pizza, the total amount of pizza we require. So if we look over on our step-by-step sheet here, first question is asked over on the step-by-step sheet, following along here. It says, how many pieces of pizza does Danica estimate each guest will eat? So we already got that answer. It says up here, she will need 3 pieces of pizza for each guest. So she is estimating that each guest is going to eat 3 pieces of pizza. Now, the next one says, how many extra pieces does Danica order? So in this case here, it's saying that she's going to order 6 extra pieces in case someone shows up unexpectedly. So in this situation, so in this case here, the answer to this one here is 6. So now it asks us, for the equation P equals 3n plus 6, what does n represent? And what does P represent? So for the n, we can say that let n be the number of guests, and we're going to let P be the total amount of pizza. So now we've defined our variables. We have let n be the number of guests and let P be the total amount of pizza. There we go. Now we can make that clear, that's all. So, let n be the number of guests, let P be the total amount of pizza. So now, over here in part B, that was the answer for A right here. B, make a table of values for the relation. So in step 2, it says, use the equation in step 1 to complete this table. Part C is also going to ask us to make a graph of the data. Will you join the points for the graph and explain? So here, we have a graph already partially set up. We're just going to need to fill it out once we finish filling in our table here. So we have the equation, and I'll put all of these equations over here. Oh, we'll get this here locked in place. Okay, so now we're going to come over here. We're going to use the equation that we have to solve for our table. So here is our equation right up here. So I'll rewrite that over here. And it's going to be P equals 3n plus 6. Now, this time we're going to replace n with the number 1. That'll tell us what would happen if we have one person show up at this party. How much pizza will they need? Now, if only one person showed up, it might not be much of a party, but we'll still figure this one out. So 3 times 1 is going to give us 3 plus 6 extra gives us 9. So the first value we're going to put in right here is 9. Now we'll redo the equation this time, but now we're going to use the value of 2. So P equals 3n plus 6. 3 times 2 plus 6 is 6 plus 6, giving us 12. So 12 goes there. So we can do this for the other values, but I think if we just do one more, we'll get the point. So 3 times 3 is 9, plus 6 is 15. And we can see here, at this point, I'm hoping that we can see that we have a jump each time of plus 3. So I can predict that the next one here will be an 18 and then 21. But just to prove that I'm correct, we'll move on to the next one here. P equals 3n plus 6. 3 times 4 plus 6. 3 times 4 is 12 plus 6. 12 plus 6 is 18. And now we'll do one more. And this time it's going to be for 5. So P equals 3n plus 6. 3 times 5 plus 6. 3 times 5 is 15 plus 6. 15 plus 6 is 21. So we were correct. We were correct indeed. So part of step 2 is finished. We have our table filled out, and that is that answers part B in question 14. Now part C is graph the data. Will you join the points explained on the graph? So let's look over here at this graph. We're going to take this table of values and we're going to graph it over here. So we have n going along the x-axis because n would be our x value, or what we call our independent variable, and p is here on our y-axis, and that would be the dependent variable. So now we're going to graph our points based on what we have here. So the first point we have 1, 9. So that's 1 along the x-axis, then 9 along the y-axis. So we're now going to graph that point at 1 and 9. So 1 and 9 would be just right under the 10 right here. And now the next point is 2 and 12, which is just a little bit above the 10, a bit close to the 15. Then 3 and 15, so that's right on that spot there. 4 and 18 right here, and then 5 and 20 right here. So now we have ourselves a straight line. Those points form a straight line. And the question is, do we join these lines here? Do we join the line? So really, what their question they're asking us is the data we have here discrete or not? So, in order to figure that one out, we're going to look at the part 3 right here, and it says, use the grid above to graph this relation. Is it possible to invite 1.25 guests? Should you join the points and explain? So this is how we're going to explain this here for part 3. It's going to say the data is discrete. Oh, I'll correct it wrong. Discrete because you can not invite 1.25 people you can only invite a whole number of people, so you do not join the points. There we go. Oh. There we have it. So the data is discrete. Because you cannot invite 1.25 people, you can only invite a whole number of people, so you do not join the points. So there's no need to draw a line connecting these points up here because the data is discrete. You could invite one person or 2 or 3, but you couldn't invite 1.5 people or 2.5 people or 1.25 people. All right, so now I believe that answers question 14C. Graph the data and explain if you'll join the points. We just did that part now. So part D says, is this relation linear? How do you know that from the table of values? And then part 2 is, how do you know from the graph? Okay, so this one here we talked about before, but we'll type that in right down here in step 4, where it's asking us, is this relation linear? How can you tell from the table of values? How can you tell from the graph? Okay, so first things first. So the relation is linear. Oh, I might as well extend this right out here. The relationship is linear, period. I can tell from the table of values. Oh. Because both N and P go up at a constant rate. I can tell from the it because the points form a straight line. Boom. So there we have it. Oh, 1 second there. So the relation is linear. I can tell from the table of values because both n and p go up at a constant rate. So if we go and we look at our table of values here, I can see that n is going up 1, 2, 3, 4, 5. So it's going up 1 each time. And as I already showed, on the y or the p side, it's going up by 3 each time. And I can tell from my graph because this forms a straight line right here. So if the line that is created by plotting the points is a straight line, you know the relationship is linear. So in step 5, it's probably going to answer part E here. If the relation is linear, explain what this means in the context of the situation. So this says, how does the number of pieces of pizza change as the number of people are invited? Okay, so what this means here is that we can say as the number of guests increases by 1, the total amount of pizza goes up by 3 plus 6 extra slices. So that's how this situation works. How does the number of pieces of pizza change as the number of people invited changes? As the number of guests increases by 1, the total amount of pizza goes up by 3 plus 6 extra slices. So that's where we get our equation that we had up top here. The total amount of pizza equals 3 times the number of guests plus 6. So every time a new guest is invited, you need to add 3 new slices of pizza. Okay, so that is step-by-step 2 for section 4.2, question 14. I hope that this video was helpful. If you have any questions, please let me know. Great.